for the bridge circuit that we're given, we're asked what is the value of the voltage V2 in volts. There's a few different things we could solve for in here, but again, this problem is just asking us for V2, but there are multiple ways we can set this up and further go through this to find the other things. So the first thing that we can do is actually redraw this so it's a little bit simpler. We can see instead of having these rectangles here, we can have some, or I'm sorry, instead of having some triangles here, spoiled it, we can have some nice rectangles. So we have a node here and we have our voltage here. Voltage here is V of x. Then we have our node right here. And so we have these resistors across here. We have R1. We have this node right here, which is our V1. And then we have our R2. Then across this, we obviously have our R5. That's really poorly drawn. Like this. And then we have our node here, which is V2. We have a resistor right here, which is R3. And then we have our ground right here. And so knowing all of this, oh, we also have our resistor R4 right here as well. And again, knowing all of this, now we can use the Thevenin equivalent to look at this, because it's asking us for the Thevenin equivalent. And when we do this, we are going to look from the inside of the circuit out this way. And what we can do is we are going to write an equation to solve for our V2. Now, there are ways that we can rewrite this to solve for the Thevenin specifically, and we're going to do this, but an easy way to rewrite this, because we're just going to rewrite it and then straight solve for our V2, since solving for V2 in this case is super easy. If we were to rewrite this, looking at these, we could short this to ground, and we would have the following. So we would have our ground like this. We would then have our Thevenin's equivalent right here. So we would have V Thevenin, and we would have our voltage like this, and then we would have our R Thevenin. And we'll go over how we get those in a second. In between these, we're going to have our R5. We're going to have our V1 here, because this is not going to change. In fact, after this R5, we're going to have our V2, and then inside of here, we're going to have our V Thevenin again. But this is a different Thevenin. This is for the right side, so we can do Thevenin left, and then Thevenin right. So now, knowing this, we are not looking at the top, again, because we've made this 0, V of x is 0. And so now we are looking at these. Well, these resistors we can see are in parallel. Once we make this 0, which is the open circuit voltage, all we need to do is look at what we have here, and we can do that because it's the Thevenin equivalent. So our RTH and our well, we do have a resistor that I forgot to write down, our RT of L, so this is RT of H, the resistor on this side, RTH of R, are going to be the following. So we have the resistance Thevenin on the left, which are these two resistors in parallel. So we're going to have a R1, and then this is in parallel with our R2. And this is basically saying, well, we have 1 over the first resistor plus 1 over the second resistor raised to the negative first power. And then this is going to be R1, R2 over R1 plus R2. And then for the right side, our Thevenin for the right, it's going to be very similar, except we are dealing with these two resistors. So we're going to have our R3 in parallel with our R4, and it's going to be very similar to this. So now we are going to look at the voltage Thevenin, and this is going to be our V2 and our V1. So we're going to solve for our V2, and V1 is just going to be extremely similar, but we are not looking at that right now. So we have this V2 right here. We know that when we are doing the Thevenin equivalent, we use the node voltage method. So we have what we're trying to look for. We have it set equal to our voltage source, which is Vx in this case. And then, since it's going to ground right here, it's over the R4 resistor. So we are having it as Thevenin, and we're looking at like this. So we're multiplying it by the resistor that this voltage is over. We multiply it that the voltage is over because it's going to ground. If it was like the other way, it would be our R3. So we have R4 right here, and then we need the total of the two resistors. So we're going to have R3 plus R4 in the denominator. And another way to kind of look at this is if we do the following, we are going to have our Vx source, right? And because it's a Thevenin equivalent, we're not looking at this resistor. We have this Vx, and then we have our R3, and then we have our V2, and then we have our R4, and then we have our ground. And so we know we have our V2 like this. We have our voltage source right here, and then we are going to ground because this is set to 0. So it's just focusing on this. So it's all happening over R4, which is right here, and then we need the sum of our resistors, R3 and R4, and that's how we get that. And so now we can just plug everything in, our Vx and our R4, R3, and that was given to us. And if we do that, plugging it into Symbol Lab, just like this, we are going to get the following, which is 2.58356. And that is going to be the answer for this problem.